Okay, so in this question we're told that fencing is used to construct an enclosed rectangular region. So let's say the region looks like that, and the area is 8,000 square meters. Let's give these sides lengths, width and height. Actually, heights are wrong because it's not a height, but that's okay, it doesn't matter. So we've got width there, height there, height there. So the fencing costs $16 per square meter for 3 of the sides. So let's say it's these 3 sides here. Okay, so, and this one here is $24 per meter. And these others are $16 per meter. Okay, so we have to find the dimensions of the rectangle that will minimize the cost of fencing, and then we have to figure out what the minimum cost is. So, there's a lot of information here. How do you get started? Well, what I do is try to start by working backwards. So we know we're going to end up with a function which is the cost. So we're going to have the cost in terms of W or H. Let's say it's in terms of W. Then, because we're minimizing it, so whenever we're minimizing or maximizing, in other words optimizing, we take the derivative of that and then set it to 0 and then solve, and then you're going to end up with the W equals something, you're going to end up with H equals something, you plug those numbers back into the function, and then you're going to end up with the total cost. Okay, so your answer is going to be, as we work through, we're going to work through this sequence here. So, what are we going to try to minimize? We're trying to minimize the cost. So let's write the best that we can do at this stage for a function for the cost. So the cost is the cost of fencing. Okay, so how much does this side cost? This first side costs 16H. Then this base here costs 16W, another 16H on the other side, and 24W. So what do we get? 32 H's and 40 W's. Okay, so there's a function. Now we can't differentiate it yet because there are 2 variables in there, H and W. But we do know that H times W equals 8,000 because we told the area is 8,000. So let's bring H by itself. So we've got H equals 8,000 over W. And let's substitute that back into the function. So now we've got C is 32H. So 32 times 8,000 over W. Plus 40W. So now we've got this function just in terms of W. Let's multiply that. 32 times 8 is 256,000 over W plus 40W. Okay, so let's differentiate. So how would you differentiate this? Well, I would write it out first as W to the minus 1. Okay, and then the derivative, bring the minus 1 to the front, so bring the power to the front as you normally do, subtract 1 from the power, derivative of 40W is just 40. Okay, so we've got the derivative is minus 256,000 over W squared plus 40. Okay, now we set that to 0. So we've got minus 256,000 over W squared equals 40. Plus 40 equals 0. So bring this over to the other side, and we've got minus 256,000 over W squared equals minus 40. So bring the minus 40 to the other side. So then multiply both sides by W squared to get rid of the fraction. Minus 256,000 equals minus 40W squared. Okay, the negatives cancel. That 0 cancels with that 0. 4 goes into 256 64 times. So we end up with 6400 equals W squared. Okay, so we get W equals, okay, that's a nice easy number, 80 or minus 80. Okay, now we can eliminate minus 80 because it's the side of a rectangle, so it can't be negative. And that means H, let's substitute that back into here, is 100. And then the cost is substitute back into here, 32 times 100 plus 40 times 80. Okay, 3200 plus 3200 equals 6400. Okay, and then looking back to what we were actually asked to solve, so we had to find out the dimensions of the rectangle. So the rectangle is 80 times 100, and the cost is 64.